Is this what I have, isn't it? Am I importing them? Whoops. There we go. Const healthcare. Okay, let me rerun because how this one is actually broken. This is pretty great, actually. The problem they line causing this error the method is not a const function, which is why you're encountering this issue. To work around the limitation, you can create your own const function that initializes the hash set. Here's an example of how you can do this. Oh, fuck. Okay. That's pretty cool. Let me just do that. Fucking yeah. I didn't think about that. So, okay, so if you create a constructor, then you can do it, but... Okay, let's go here. And we need the struct, actually, right? Oops. Health check outputs. There we go. That should fix that. Equals health check outputs. Cool. Does that work? Just okay, so that's not a mistake. Okay, that's just saying it returns that. Wait, do you not use return in Rust? Oh, okay. Now let's try and run it. See if we got it. And then we're gonna pull that out into its own file to make this file a little smaller. And we can't do that. What the fuck? How to make a constant hash set. Rust. This doesn't work. What the hell? Why? Oh, you know what? Oh shit, so but let me copy this and undo it. Copy this. And we'll go undo all of that. Bunch of opcodes. Freddy 1 and 2. Now let's see if it works. Allowing. I do not understand. Okay, this is exactly what I want. Cool. I think if I can pass constant variables to it. Let's go here and do that. Where's PHF? Fuck, I don't want to add another unnecessary dependency. Use compile time static collections if your data is treated static and then compile. Consider using the PHF crate. Provides compile time static collections. For example, you can create a constant map using PHF. Okay. Yeah, fuck it, let's just do it. Sounds cool to me. And we'll do, this probably won't work. I probably got a hard code on, but I can maybe use macros. Is it still installing? Oh, if I do static macros in Rust. Macros. Okay, let's go back to here. PHF. Still installing. Really gotta get better at Rust. be right back while this is setting up. Alright, where are we at? Still going. Still going. Okay, looks like it finished installing. Where are we at? PHF map, I don't know. Not sure what that's for. But I'll enter. Unresolved passes, no quick fixes. Maybe that's just, I don't know. Let's see. Okay, so we got that. Let's see if we can use our constant variables. Health check send opcode. I don't think that's gonna work. Okay, I don't think that's gonna work. Let me read more about PHF. Is that what it's called? PHF. It says not macros. What are C type dev Rust C macros? So I'm thinking like what C does with macros. Yeah, where it's like it'll at compile time replace, like, say your limit with 5 in the line, and it's not a variable, it's just basically copy and paste, right? So this here, this limit at runtime would actually be hard coded to 5, basically. So it wouldn't be a variable, it'd be the same as if you wrote 5 there, but you get like the variable like shareability of it. So that's what I'm kind of looking for. C macros in Rust. Rust macros are very different from macros in C. Rust macros are applied to the token tree, whereas C macros are text substitution. Okay, so they're different. They're not what I thought they were. Declarative and procedural allows you to operate on the abstract syntax tree. If the Rust code it is given, a proc macro as a function from a token stream or two, or another token stream where the output replaces the macro invocation. Let's go back to Copilot. PHF map macro generates a hash map that is validated at compile time. So this isn't gonna work, I don't think. I think it's gotta be like hard coded static. Okay, so let's get back to the other one. Implement your own constant default since the default traits default, but I don't get why this says it works. Am I using the wrong import? Like, no. Oh my gosh. This doesn't work. I don't understand. Who wrote this stuff? Edit this code on GitHub. How to declare constants? It's me. Constants and hash set. Oh my gosh. Maybe I can just remove const from it. I don't know. Let's go just comment, go revert that back, just get the raw code that it was. We'll do this and we'll just do let. Nope, we won't. Why can't I do let here? Bind a value to the pattern. So like, does this? I guess, try that, I guess. Actually, this is fine, right? Because I'm not declaring it as mutable. The only thing I wanted to do is make sure this never gets modified, but in Rust, you have to modify this, you have to actually put the mute in front of it. So that whole, like half hour I spent trying to figure this out, it's complete. It's still, cannot call non-const fun in statics. You know what, actually, is to create global hash set Rust. Remove values from hash set in Rust. Get rid of values in hash set. Hash set with default values in Rust. Right, which is what I had, or am doing basically. I don't want to have to create it over and over again. Union of two sets. If I do this, decentralized package. Okay, so we got those there. Let's go to let's see if I do static pub. Okay, I think I may have figured it out. Hopefully. Now let's move this up. Okay, alright. Let's see. I don't know. It's kind of annoying that, like, the ID doesn't tell me all the stuff that fails when it builds, but it's still pretty new, so, and in pilot program, so cannot refer to the associated constant of trait. Use the fully qualified path to the only available implementation. Okay. Oh, you know what? Is that because again, we'll do health, check packet, and we'll try again. Not sure. Like, why can't the IDE tell me that before I go to run it? That's what I'm wondering. Okay, so I guess I have to copy this like this. Maybe. Is that a shot? Rust maps. I'm just gonna look up maps. Rust line maps. Hash set. Sets. I'm gonna figure this out because this has been an issue for me for a while. And implementations, random state with capacity, iter, when is empty, drain, extractive, retain, clear with hasher, capacity hasher with hasher, hash set, reserve, try reserve, strength of fit, strength 2 difference. Rust lookup const rust set constant constant set rust. So say if you wanted to compile a constant default string value for a field, have a compile constant could at runtime later be replaced by heap log. Or if you want to have an actually constant field, this doesn't really make much sense in Rust, and you should consider just using an associated constant. Okay, associated constant, what is that? Trait variable Rust. Rules for implementing traits. Create be whatever. I'm just gonna, fuck it, we'll do fun, get health, check, opcodes, set, u8, hash set rate. Turn this. Okay. Alright, let's try it. We'll just do that. I just feel like that's less efficient, but if not, then compiling, didn't fail yet. It compiled, it looks like, for the first time in like an hour. And it ran, but it failed. Test failed to rerun pass piece for the did they all fail? Let's see. Left. So we expected here. Try it again. Is it because I had that semicolon? Oh, wait, which ones? Oh, just this one failed. Oh, invalid opcode, okay. Okay, so actually nothing was wrong. That's because we added the opcode of 2. Right? So 0, 1 and 2. Okay, so we need to make this 3. Okay, and now it should pass because that's an invalid opcode, the other ones are valid. So see, nice thing about the tests is they caught that change, that change that broke the test, and now I saw why and was able to fix it, and made me think more about the change and if it had any side effects or anything like that. No big deal though. And it passed. Fuck yeah, dude. Invalid opcode received. We're good. And let's see. Should we clean up some of this stuff? Nonce index. Let's go here. Plus nonce index. So I'll use that instead of having a magic number. Run it again. Just a double check. Should be good. Kitty's over there sniffing on the plants. Cool. cool. Yeah, so we got that test done. That's good. Just get rid of all this now because it's none of it's gonna be used. Okay. Eventually, I'll pull all of these probably into a constants file, maybe if I can. Maybe not. We'll see. Okay. Okay, so where are we at? We didn't get anywhere we expected to get, so let's see. One sec. Okay, we're back. Health check, right? So here we are. We still were working on the John. Let's see. This is this. Okay, network. Let's go to network. Comment that out. Let's comment that out. Actually, not screw it. We're not even gonna check this because the serializer will do it for us and then return a response. So got the buffer, got buff vector converted to the vector, passing it deserialized. Now we'll do so if health check packet dot header equals let's see, we're gonna have to make some of these things public, so so what do we need? We need the opcodes, right? So I'll do pub no opcode, pub syncode, pub ACK opcode. Okay. So if header equals health check syn opcode, then we're going to send back a response of a acknowledgement with the same nonce. So we'll do that. We'll package up the packet in the proper format. So we'll do let response. Actually, let's make it out here. Let response object. Let mute response object equals what is it called? Health check packet. Oh, there's a from tick. So from health check package, and then we'll do. Okay, so I just moved it, so I can't reference. Okay, let's just do health check packet clone. What? What's that? What's that? This function takes one property but zero were provided. What? Fill in missing arguments. No, wait, that's not right. Why is control V clone? A little bit confused there. Oh, okay. It's because I'm doing it wrong. I'll check packet clone. Clone. Okay, so now we have two copies. Now we'll do health or response object dot header equals app opcode. We don't need these things here, so let's delete those. Else if health check packet dot header equals ack opcode we're going to, in this case, update the network table. Update the network table. Okay, so we're gonna update the network table, and then else if we'll do, and so this will be the unexpected case, and so what I want to do to be safe, so in this case we would just do nothing basically, right now at least, because it's unexpected. So but what I want to do is check for any modifications to the supported health check opcode. So like say we add a new opcode here, but we forget to update this, and so like it's not either of these, I guess in the else we think that's unexpected, but we added a new supported opcode here. So I just want to do like a double check and be like, all right, is this actually a valid opcode? We're just not handling it. If so, just like log something. Otherwise, whatever. So the only way it would the only happy case way it would get into this flow is if we received a no op opcode, which right now is like we're not planning on doing that, so it's unexpected. But yeah, so we'll do where is it? The get health check opcodes. So pub there. Do if get health check opcodes dot contains health check packet dot header, and I can't do that, can I? Because I changed scope. Okay. Health check packet header, and it's because it probably moved, right? Because I already referenced it elsewhere. Oh, okay. That's it. So it's just this. And then, so if that, print line, valid opcode provided, but not handled. Else print on, and I would like to print errors, but invalid opcode received. And then we'll do this, and then we'll do health check packet dot header of that. Okay. Now let's put brackets around this so it's clear that those are coming from the response. Health check packet dot header. Probably should name header to opcode to be clear, but whatever. Let's go. Okay, so we got our invalid case, and then we'll just here return, or what do? We just do okay. Turn okay. Yeah, there's something weird about the semicolons, including them or not including them. Oh, what is this? I don't know what's gonna happen there. Socket.send. Okay, so then we're gonna take our okay, so let buff, okay, let buff equals buff amount. We're gonna do we're going to do health check packet size. Right? Why is that? Okay, so it's like that. Nah, let's see, buff. Let buff equals and mute. Response object dot serialize dot to or dot expect try into expect okay, and expect health check response packet serialized to U8 array. And I guess I probably have to keep this, right? You're doing not. I don't want it to be mutable, really, but okay. Socket send. Okay. So now we got that. Okay, and let's try and compile it, see if it will actually compile. Probably won't. So I have no idea how this works. We'll run it. The trait bound is not satisfied. Try into the trait from vec UA is not implemented for and UA, which is required by the it should just be 2 array, right? Wait, what is serialized return? Do I even need to? Can I just do that? No, I can't. Okay, so how did I do it above, right? I did buff to vec, right? But above that, and then alright, let me just, I know how to like do this. I just feel like using the language features to do it. Convert vec to buff array rust. this is, I don't think what I'm looking for. Russ, is there a good way to convert back to an array? Arrays must be completely initialized so you quickly run into converters up. What to do when the converted back to array with too many or too few elements into an array. Phone demo. Trying to unwrap Rails. Okay, 2 minutes. Health check. Oh man, let's go back. Health check. What did we do? So we just like straight up. Okay, so I just screw it. I'll just do this. This. I'll just do it the programming way, the way we always do it. Health check packet size. Health check packet size. Health check I. And warning. Buff. Response object that serialize. Supply, buff supply is raw supply. Okay, let's give that a shot. Just quick build. Compiled. Hell yeah. Okay. So we got it. Let's do let's so we have our receiver, and now we'll want our sender. So let's go there. Let's make these public too. Pub health check sender, and health check receiver. We'll make that public. And what we're gonna do is we'll change the port here. We'll make these constants are configurable in the future. So this is 5.0. We'll make 5.1 the receiver, so that they are on different ports. Okay. And let's see. And all of this logic can be shared. Like all of this handling logic here should be kind of shareable. But we're just going to reverse this, right? We're going to take this, just delete this, go up here, like that, and we're going to change this to request object equals let health check packet it's going to be header header of we'll do send call, and then we'll do nonce, and we're gonna just we'll take something from here, and we'll like modify it a bit so it's a little different, so that like we don't get any issues with like okay, just make it a little different. Okay. Request object, we'll do request object.serialize. Copy it over. Source, where does source come from? Source comes from probably the request. Wherever that is. Receive, right? Buffer, and then we get source, and yeah. Okay. Socket address. Okay. Let's go. And end source. What is source? Is it descriptor? Socket address. Okay. So we want to do socket DST. So let's do destination. Let DST equal so source, what is source? Socket address, okay. Socket address, new, and IP import. So let's make constants for these. Const IP equals this. Const sender port equals 3451, and that's the receiver actually. So we'll do and then we'll go like this, copy this, go like this, go like this, and then sender port receiver, and this will be a string. What do we need? string reference, a striv reference, or a real string. So let's go new, and it's okay. So it's actually a U16 IP is an IP address. Okay. U16. There we go. And then IP would be 127.0.0.1. Actually, in const IP would be, we're gonna make an actual IP address. V4. Does it take in? Fill missing parameter. String. Parameter associated from string. Okay, so let's find UDP. Create IP address. Okay, let's go here. There we go. So I don't know why IP is missing the type for const. Oh, okay. IPv4 address. Okay, got the address, got the port, got the, we're good there. And this is binds. Okay, so we can just do IP. I could have just used localhost, I guess. Okay, whatever. IP. IP, comma, receiver port. Is it and IP? IP address. Continuous IP address. IP address. There we go. Got the destination, so we're sending it there, and then we're going to let Does it return a result of view size? Okay, and now we got this. Mute buff. Receive from. Okay. Yeah. So actually, it seems that I can receive data from anywhere, and it's not going to be guaranteed to come back from this address I'm sending it to. So that's going to add a little bit of difference that we'll have to take care of. But for this, just to get it to the point where we're making the request and getting responses, I'm just going to listen for whatever comes back next, and then assume it's the remote host that I sent the initial request to. But that's the nice thing with the nonce is like if it's not the same, then it's we basically know it's not coming from that same source. So yeah, let's just keep going. Receive from. Okay. So this section here. Check favicon. Okay. So socket received from. Okay. Print line. Print line. Health check. Back up code received from. Let's do. See from. See. Actually, you know what? Ready? Watch this. So we're just going to. Okay. Print line. I'll do. We'll do response object received. And we'll go check our formatting. Go like this. Go back. Get that. Go like that. Got that. And then let's just copy this and go here and do response objects. Let's see how check packet. from build. Built. Now let's go to main. Let's do some. Let's this. We'll make a new main. We'll do main serial. Main serialization. Let's do a new main. We'll go ahead and we will. We'll do health check receiver, health check sender, and we're gonna put these in threads so they can run async or independently of each other. Otherwise, they'd be blocking each other, and it wouldn't work. So we'll go to the Rust documentation again. We'll do not that. Is it thread? Using threads to run code simultaneously. So I'm eventually gonna have to use channels, right? But right now I'm just gonna do this simply. Okay, so this is how we start a thread. We will go like this. Just put that there. Go like this. Go like that. We'll change that. We'll copy this. We'll undo that. We'll paste this. I accidentally copied again, and we'll do health check sender. Whoops, go like this, import thread std. And I just saw that it had a Windows specific one, so I'm not sure if this will work. Okay, so we need that handles. Let receiver handle equals I before E except after C. Let send handler or handle receive handle dot join dot unwrap. Okay, so this is our driver code basically. So we create two threads, one for the receiver. We create that first because that kicks off, and then in here, whoops, undo that. In here, we basically start by opening a socket and then waiting to receive a request, and it'll be blocked here until it receives a request. So we want to run that first so that it's ready to receive requests, and then next we spin a thread up to for the sender end of it. So it'll send that message. The receiver will be awake and ready, take it, and then down below we wait for them to complete basically. And so that should work hopefully. Let's see. Let's run that. Probably won't work right away, but getting closer. Warnings. I also don't know if I updated the IPs correctly. Ooh. Did it work? Received health check packet. Nice. Still running though, so something's not right. Received health check packet. You know, what are we sending though? I forget now. that's the SYN call. So the receiver got it. You know what? Maybe. We know. So we got it. Received. So we got down here. Received. And we come down. And what do we do? Oh, I got rid of the. Is this? Oh, I got rid of the callback code. What? Oh shit. What'd I do? Okay, so I commented out all of this. Forget why. So let's just go and uncomment that out, and this should send back the response. I just got serialized buffs, send buff source. Okay, and we set the. Okay, let's give it a shot. Stop and rerun. Nice. Fuck yeah, dude. That was just our code was half commented out. So cool. So now we see the health check packet. The sync call was made. It was received by the receiver. Had the data, and then receiver sent back with the opcode the acknowledgement and the same nonce, right? So our health check network layer is basically, I mean, I want to do more. Like, I want to make the header probably contain, like, have it actually be a data structure that contains an opcode, and then maybe some reserved space for future usage, like a few bytes or something. Yeah, so cool. So yeah, it's kind of what I wanted to accomplish for this video. And we're very early in it. There's a lot of like, this is very like the probably the lowest level it'll get, and kind of want to build the whole network discovery thing and stuff. So this is the basis for it, but be good to create that network table to actually know who you're actually synchronizing with. But I know I'm gonna have to restructure this because I'm gonna have to, because there's gonna be one socket for all health checks, and so in this case, right, like we were only calling once between two hosts, and so the way we wrote it was guaranteed to basically, handle it properly. But we're gonna have to have some sort of mechanism for handling different peer-to-peer health checks asynchronously and out of order, basically. So we can't just send a request and then take the next response and expect it to be the same host sending you back that response. It could be any host sending it to you. So we'll have to synchronize that, basically. And I think that channels, if it's what it's called, I know in Go I think it's called channels, but so they call it messaging. So we'll have like a message consumer that will I don't know, we'll forward this information to another component in the project that will map the request to the proper network table. I have it all in my head. I don't know how to kind of explain it very well, but yeah, anyway, so this was a very slow and long wanna watch me code, but we still accomplished something, so that's nice. So let's go back to the notes and just recap what we did. So we basically, so we did this, so it's done, kind of, so I'll say POC done. We'll do send response if it is running alive and healthy, so POC done. And then to do, right? We didn't actually do the routing table yet. Cool. I've been doing this for a while today, so I'm going to take a little break. Might be back today, might be back in a year, I don't know. But we'll see. So stay tuned. Have a good day, everybody. See you in a bit.